and welcome back, Mindsetters. I hope you had a nice little break there and you went and did whatever you had to do, like I always do. Now it's time to you switch off the iPod and whatever else you have that's distracting you, and time to pay attention. Make sure you have your pens and pads out and you're ready to make notes, because we're about to continue the show with Dina. And make sure you do not disappear or just phase out. Make sure you're paying attention. But also, don't forget, right on the Facebook page, let us know where you're having issues, if you're lost anywhere. But on that note, as I hand over to Dina. Dina, take it away.
Thanks, Ty. Yes, my calculator froze just a little bit earlier, but my calculator is back and unfrozen. So let's have a look at that value. We were looking at the 108.6 degrees. That was the obtuse angle. Let's go and use it in our calculation and remind ourselves that whenever we've got a cos equation, there'll always be two formulae for the general solution. One of them, the 108 that the calculator has given me. What will the other one be? Negative 108.6. So let's go and do that. There we go. A plus 40 degrees is 108 plus K360, or that equals negative 108.6. Now we're ready to solve for A. Can you see how earlier we weren't able to solve for A because 40 degrees was part of the angle? Now that we've got the angle out, we can now take 40 degrees away from there. So we get that minus 40 degrees, which is equal to 68.3. And angles are usually rounded off to one decimal place if you're not given any instruction. But just look at the instruction just for confirmation that you've got the correct number of decimals. Usually in a grade 12 paper, they often say 2. Practically two decimal places in angles is quite non-unpractical. So 1 for angles would be sufficient if you haven't been given the instruction. Okay, so that's 68.3. 6 degrees, and now you've rounded off because it's your final answer, plus K360. And we've got here, it would be that minus your 40 that you are solving for, so it would be minus 148.6 plus K360. And somewhere, doesn't matter whether it's this side or that side, we must say that K is an element of the integers, so that when we are finding values, we're looking at 1, 2, 3 to substitute in. Remember, they're periodic over cycles. There's no such thing as a half a cycle or quarter of a cycle. Doesn't work. They're not fractions. They're actually integer values. Okay. What about this hence? What does hence mean? Hence is a very powerful word in mathematics. And what it's saying is, now that you've worked everything else above, utilize that to carry on with the rest of the question. So you must use what's before. If they say hence or otherwise, it means that you can choose any method for the next set of questions. However, if it only says hence, you've got to connect what you've done with where we're going. And let's see what it says. If sine A is negative, calculate what tan of 2A over 2 is. Correct, look here. We've got 3 decimal places that we need to work to. Okay, so some very important information. We've got sine A has to be negative. We want to calculate the tan of that correct to 3 decimal places. Okay, so how do we connect this little portion here to what we've already got? Okay, well, originally, can you see that we've been given that the cos of the angle is negative? So we've got cos of an angle, and that is negative. Okay, so that's what we've solved for. We've solved for when is that ratio negative. At the same time, we want to connect it with sine A is negative. And I find it very easy if we just draw a little picture to indicate the possible quadrants that would give me, it certainly would give me where cos is negative. And that would be in quadrant 2 and in quadrant 3. But now we also want where sine of that angle is negative. So we would now choose that sine is negative there and in there. So we actually want only the angles that would be found in the third quadrant. And if we look at 68, 68 is quadrant 1, but if we look at minus 148 is what we're looking for, because this would be 0 degrees and this would be a negative angle rotated in this way, so that's minus 90 and that's minus 180. So a negative 148 would actually be a third quadrant angle. So this value here is not good because it gives us both as positive. Okay, so can you see how cos and sine are both negative? So we're actually looking for one angle that would make that true. That's one of the possibilities. So we would get that A could be the negative 148, 6. Okay, and now we want to find out what is the tan of twice of negative 148, 6, and we're going to divide that all by 2. This is actually written incorrectly. We should actually have a tan 2a that we're dividing by 2. So this division here is the whole of this tan there. Okay, so our A is that. So again, we can use our calculator. We've currently got that. So if we add a plus 40, we get that. If we take the negative of that, we get negative, which we then took away 40, which gave us our negative 148,6. And what we'd like to do is to find out what double of that is. So it's 2 times our answer, which is that. We want to take the tan of it. We get that, and we divide by 2. And we get to 3 decimal places, so we need a 9, a 7, and a 0. So it's 0,97. And that would be our final value, obeying the instruction of 3 decimal places and making sure that both sine and cos are negative, the given instruction, the follow-up instruction, and then we'd had to work on A. And you'll find very often that your solutions that you're finding, or your general solution that you find, will always have a follow-up to it. And we actually didn't take into consideration that originally we were actually given that domain. And in that domain, the values that fall into that set would be not a 68, but that one would have fallen in. If I take 68 minus 360, that would have fallen into that set. So just to end off, we need to connect the domain with the final solution and say, therefore, A could be part of the set that has that 68 minus 360. So it would be a 68,6 minus a 360, and it would be this value of negative 148,6. So it would have 2 solutions. So that later on, when you're doing your check on sine and cos, you're actually doing it on A, and you're doing it on those 2 values that you've got. You're not doing it on an infinite number of angles, because now we'd have to keep going and saying, okay, here's my angle that I'm talking about. If I then rotate 360 degrees, I'm going to get another angle. If I rotate another 360 degrees, I'm going to get another angle. So I would get an infinite number of angles, and I'm only looking at this one value here. So looking at the general solution and then qualifying it or quantifying it and saying, hang on, what was my domain that I was operating on? So I've only got one angle to work with, and then as a follow-up, we would work out any further calculations that we were dealing with that angle. Okay, let's have a look at some of the questions that you've been posting on the Facebook page. And the first one is a question that says tan of 2 beta plus 60 degrees is equal to negative 2,5. So when you're focusing on the equation, you're saying, has my ratio been isolated? So as a checklist, I isolate the ratio. Has that happened? Okay, yes it has, because I haven't got any coefficient, i.e., have I sorted out the coefficient, and have I sorted out the constant term. And the constant term, there's no constant term. There is a 60 degrees, and the temptation is to get rid of the 60 degrees onto the other side. But this is 60 degrees. So it's going nowhere. It's sticking to this bracket when I extract it from the ratio, and I'm only now looking at the angle, because I cannot connect it with a negative 2,5. Okay, so out of sine, cos, and tan, the easiest general solution would be your tan, because you've actually got a period of 180 degrees. So we've got an isolated ratio. We are ready to use the calculator angle, because we now have that 2 beta plus 60, the whole of 2 beta plus 60 degrees, would be equal to the calculator angle plus K180. Okay. I don't have to have two formula. I only need one, because my tan function is periodic over 180 degrees. My tan function, tan lines. Okay, so let's go and look at what the calculator's got. See. Okay, so we've got, let's clear it all. Let's go to my tan function. I want it of negative 2.5, and I get an angle of negative 68,1. Were you expecting that? If the calculator is giving you negative 68, you happy that the calculator is possibly making a right deduction? Or do you just say, no, I don't believe it? Well, if we look at the tan ratio, it has to be negative. So where would tan, in your Cartesian plane, where would tan ordinarily be negative? That would be quadrant 2 and 4. So the calculator has been programmed to give you the fourth quadrant angle in its negative format. Wonderful, because it's a very tiny angle to work with. It's not giving you the obtuse angle. Okay, it's giving you the fourth quadrant angle. So all we have to do is copy it into there, and see where we go from there. Right, so 2 beta plus 60 would then be equal to what our calculator gave us, negative 68,19, negative 68,19, etc., plus K180. Once you've got it to this format, now you solve for the angle. Okay, so you capture the whole angle. We call this a complex angle. So it's not just a theta or a beta. It's got a coefficient. It's got a term. Complex angle, you keep it together until you find the calculator angle. Now I can solve for beta. How do I do that? I'm going to minus 60, and I'm going to divide by 2. So let's minus 60 from there. And let's see what we get. There's minus 60, and we're going to divide by 2. We get negative 64,09. And remember, I said to you, round off to 1 if it's an angle, unless otherwise instructed. So we're going to round off to 1. So that would be negative 64,1. So we get beta equals negative 64,1. And we first took 60 away, then we divided it by 2. So if we divide 180 by 2, we're going to get 90 degrees. Okay. So for the mindsetter who was looking for that solution, your beta should be that. And remember to give K a value. Most common error with this question is to try and get rid of the 60, which you can't. Complex angle stays complex angle. Go fetch the calculator angle and then solve for beta. And remember that if you're dividing by 2, this is 2 terms. So we're dividing the 68 by 2, and we're dividing the second term by 2 as well. Or if we would say divide the whole right-hand side by 2, we can't pick and choose. We have to divide each term by 2. Otherwise, you break down on the algebra. Okay, and then... yeah, we'll leave it at that. We'll take a short break.
All right. And that is courtesy of Zubuya. Thank you for posting that question. Again, mindsetters, if you have any questions that you need help on, make sure you just post them on the page, and I'll make sure that I at least attempt to get them to Dina, because we've got a lot of stuff coming in. So mindsetters, I'm saying to you, post, and other mindsetters, if you see someone in trouble, what I always say, help out. But on that note, we're gonna see you after this break.